Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back over here working on this Sellers drill grinder. I introduced this to you in a couple of episodes ago. New machine for the shop, at least new to me, and got it kind of up and running on the last episode, but now I'm getting ready to start getting it a little bit fine-tuned and a little bit more usable for at least being able to use it until we can work this in and do a full-blown restoration on it. One of the challenges that I told you, shared with you I had before, is I need to come up with a way to dress this wheel. This has got a grinding wheel on it and it needs to be dressed from time to time. Right now I can tell just by the initial grind that I did that it's not flat all the way across and it needs to be dressed. Now in the manual it actually shows what the original wheel dresser looked like for this, and I'll show you a picture of that. Not something that's going to be very easily recreated. We're going to require special castings and some other things, and just really don't have the ability to do that one, at least not easily. But I think I've got another solution to do this, where we're just going to basically take a regular diamond nib like you would use on a surface grinder or something like that, and come up with a little fixture to hold that diamond to be able to go across there and be able to grind that out like we need to. So that's kind of my game plan here, is to come up with a fixture to hold this diamond. And before I do, let me show you at least a blueprint of what the original wheel dresser would have looked like for this machine. And then I can show you my game plan on how we're going to come up with a fixture to hold a diamond to kind of do what the original was intended to do as well. So I've got a copy of the manual for this machine, and in the manual it shows us a little blueprint of the assembly of the Hacker wheel dresser that would have been used on the 4G and 6G models, which would include this one right here. And basically it's a piece, you see it's got a center on the end, it's kind of a piece of round stock, it goes out and bends, and then it has two little tabs here that kind of emulate the edges of a drill bit that you can actually chuck, and the little chuck that this thing uses to hold the edges of a drill bit. And then it had a little wheel on here. You can see a little wheel with little holes in it that would have been used to actually grind the wheel. Now I have from my other little Sellers drill grinder this piece, and it's got that same type of wheel in there that's got the little holes in it like is in there. This one looks like it's pretty much worn out. It's lost all this diameter, but I think that was the type of tool that they use for dressing it, which is, I don't even know where you can get a wheel like that anymore. But what my game plan is instead of using this, we're just going to use a little diamond nib to kind of accomplish the same thing. So there's a diamond. This is one like you would use on a surface grinder. You just make a little fixture. It's got a diamond nib there in the end, and you would run that across your wheel and dress it. And this is, again, is what I'm thinking I'm going to use to actually dress that wheel, instead of that little wheel like was in the original. Now, the challenge, I guess, and I've got a solution, or at least an idea, is I need to come up with a way to mount this in here where it will hold this in place firmly, where we can then move that wheel back and forth across it. Let me show you what I came up with there. So with a normal drill bit, the way this system works is you got these little fingers on the side that catch that little rim of the drill bit, and you can move these in and out for different diameter drill bits. And basically your drill bit would just be caught between those two fingers on the edges there, and then your drill bit is supported by the center on the other end of it to line it up, and then that is what would hold this in place. So my thought was, well, maybe I can use something like a drill bit that has some flutes in it like such to grip a hold of, but I really don't have enough metal left in the web there to drill out a place for that, the piece for the diamond to go down into. But I got to thinking, I had something in my cabinet over there that I've never used that I thought we might be able to use as a substitute. So what I've got is this, I don't even know what you call it. Basically, it's a drill. You put an end in here. You could put different diameter bits in the bottom down here, and this could be used for drilling out big size holes. This is something that a viewer sent to me a long time ago. I've actually got a couple of pieces that fit up in this. I've never had a need for it or used it for anything. And honestly, you know, for the stuff I do, I probably would use a drill bit anyway. But I was thinking that what we could do is kind of cut this end off down here. Now I got a lot of metal in here because this does not have a lot of webbing like a typical drill bit does, but yet I got these little flanges on either side opposite of one another that this can hold. So my idea here is we would cut this off at the angle, I think it's 118 degrees, same as for the bit thing there, and then I could come in there and cross drill into that where my diamond could be supported. So basically my diamond this would kind of be at an angle about like that. So, you know, we would cut this off where it's running straight across in relationship to the wheel, and then the diamond stick out roughly 90 degrees. It doesn't have to be perfectly square, it just needs to be where that diamond can go across that wheel and dress it. So I kind of hate to hack this piece up, but I've never used it, I've never had a need for it, and this is an application that I can use it for, and I think that this is just going to serve me better repurposing this into what I need rather than just being a tool sitting in my cabinet that I may never have a need for. Anyway, that's kind of my thinking. Let me show you how it would mount up into the actual chuck and show you how it would hold it. So this just would fit right into the support down here for the tailstock, and we've got places here that they're not flutes, but they're kind of flutes. They're going to work as flutes as far as my chuck is concerned. I can grip a hold of that. And now I've got something that I can mount in here that I think can hold my drill bit. I just need to kind of cut this off at an angle roughly parallel to the chuck, and then drill that hole in there where it'll go. So that's kind of my game plan. I think this is what I'm going to do. Like I said, I kind of hate to mess that piece up, but it's going to be more useful to me in this form than the way it's currently being just sitting in a drawer. All right, I'm going to take a Sharpie pen here, and I think what I'm going to do is just kind of drawing on here. This doesn't have to be perfectly square because that point's going to follow whatever angle I want to. It doesn't like I have a flat or something that has to line up on it, even if that point's at any kind of a different angle around here. When we move this wheel back and forth, it will cut on there. So I basically need to just kind of lop this off at that angle and then drill a hole in there to put my tool in. All right, I got this set up now over here on the Marvel saw to hopefully saw that off at the angle that we need. I'm hoping this is soft enough. It should be, I'm pretty sure, for this to cut. Yeah, I'm almost don't want to start because I hate to ruin this thing, but like I said, I'm repurposing it into something more useful for me, so here we go. Just let that cut across there. It is some pretty hard steel, but it is cutting it as well, so I think we're fine. All right, we got it. All right, there's our cut. I knew there was a hole in the middle for coolant. I didn't realize there was 3 holes in there. Hoping that doesn't mess me up on my plan. I think we should be able to find a spot in there to drill a hole kind of across there like such, and then we'll mount that nib in there. All right, let me figure out how I'm going to drill that hole. I got my part mounted over here in the grinder, and I don't know how well you can see. My cut's pretty good, but it's not really perfectly in line with everything. And I was like, well, how can I straighten that out? And I said, well, I got a grinder. I can just grind it right in. So I think that's what I'm going to do is we're just going to kind of use this and swing our stone back and forth across that and kind of dress it up so that it is actually in the right plane with the grinder. that's my game plan. Let's see how it goes. Don't want to take too heavy of a cut here. Just rocking that wheel back and forth by hand, bringing it in a little bit at a time. This is kind of how the dresser will work, except it'll be going across a diamond there. But right now, we're just going to use the wheel to grind that bit that we cut so that it is, let me get an idea of where we're at. Yeah, it's a little bit high on the top. It's pretty good in line this way, but my cut over there, it needed, right now it's tilted out in the top more than in the bottom, so I'm just cleaning it up here. And I may have to go ahead and tighten my belt up over there. It's slipping. Yeah, I'm gonna have to tighten that belt up. All right, we're gonna start by trimming this, the lacing off of this old belt. I've got a belt cutter here, a little guillotine action. You know how much to take off? I'm only going to take off probably about 3/8 of an inch. I'm just going to basically clip off this old lacing here, which will shorten it up by, yeah, about that much, maybe just a little bit over that. So that's what we cut off, which is probably not quite half an inch total of the actual belt length, not counting the lacing. And we'll go ahead and I got some fresh lacing here. We'll cut us a piece the right width. All right, we'll go ahead and put this lacing in here. Go ahead and open those jaws all the way up. Take my pin, we'll pin them from the bottom. That captures all the hooks in there. And we'll lace that together. A little bit tighter. That should do it. And those will splice together just fine. Let's go put that back together. All right, let's go back to my grinding. Much better, much better. No slip in there. Feeding that wheel toward me just ever so slightly each pass. All right, I've got that ground down almost all the way to the bottom. It's down far enough that I can work off of it. I'm just going to let this cool down real nice and slow because that did get pretty hot grinding it. And I don't want it to get any harder than it has to. For my drilling. So anyway, we're gonna let this cool down. Ironically, that grinding project we just did there probably dressed the wheel, got it flat compared to what it was originally. But we need to be able to dress it with a diamond. So we'll be able to do that going forward, hopefully. All right, let me let this get cooled off and we'll see if we can get a hole drilled in it. So guys, I've decided to take this part, this bit, and anneal it to make it softer. That was pretty hard when I cut it with the bandsaw. I still got to drill a hole through there. And then also when we did the grinding, we heated it up. It got hot. I saw some temper marks in it. So to counteract that, what I want to do is I want to heat this up and let it cool down real slow, which is the process to anneal it, which is to make it softer. That's how you make hard metal soft. To make metal hard, you heat it up and you quench it, cool it down fast, and that'll make it hard. And then to anneal it, you do the opposite. You heat it up and let it cool down real slow, and that will make it in a more softer state. So I'm just taking my torch. We're heating this end up to cherry red, about like such. And what we're going to do now is just take this and wrap it up in a welding blanket and let it cool down real nice and slow. So I got a welding blanket here. I'm going to put this over in here, and I'm going to wrap this up. And then I'm going to wrap it up in another blanket on top of that one to give it plenty of insulation. And then we're just going to let this cool down real nice and slow, probably over several hours. And that should soften that up and make it easier to work with. So I'm getting ready to drill the actual hole through this. And to do that, I'm going to be set up over here on the horizontal milling machine. Even though I'm drilling and not milling, this is going to be the perfect setup for this because I am going to be need to be doing it horizontally. I've got a drill chuck that's just mounted up in a 50 taper tool, and we'll just use that to come in. We'll just feed the table in instead of feeding the quill out. We'll feed the table into the work and do that. So I've got a center drill in here right now just to kind of be using it basically as a just a starter bit to get a hole started. Then I'm going to put a 7/16" drill bit in there. We'll drill a hole all the way through this, and that will basically allow that diamond to fit up in there. Then we'll cross drill a set screw into that to tighten it up. That's my game plan. Let me get over here. I need to kind of get this thing positioned where I want it. And ideally, I'd go right in the center of this, but because there's already a hole in the center, I'm going to probably have to offset a little bit. There's actually 3 holes in the end of this, so I'm going to have to offset a little bit to kind of find me a place to get a hole started that I can go all the way through. But that should be just fine. So let's get in here and do this. I can control all of my axes back here from the back side of the mill. And that's what I'm going to be doing to get it kind of positioned where I want it. Alright, I think I kind of like that. I'm kind of looking in here, making sure I'm kind of where I want to be at. I think that'll work. And now I'm just going to bring the table in toward me. I'm just doing this by hand feeding it right now. And again, we'll start by just putting a little dimple on there to get a drill bit started. And I'm going to back out and we'll put a drill bit in here. All right. I'll come back in. That drill bit should start right there on the hole we just started. I'm going to speed this thing up a little bit. All right, that's about 604 RPMs. My drill chart says 693 for a 17/16 drill going in steel. So we're just going to go with this. And that annealing seems to have worked good. I'm going to get a little cutting oil and put on there. Let's put a little oil in there. Yeah, I think our anneal job did a good job of softening that metal up compared to what it was. That sound you're hearing there is probably going through some of those holes that are already drilled in there, getting a little bit of an interrupted cut on it. I'm going to drill this all the way through to the other side. And it's drilling really nice. I'm going to get a little oil back up in there. I can see some heat on it. Uh-oh. Yeah. I think we're all the way through. Very good. So I don't think I showed it, but when I was setting this up, I took a square and just butted that up against the front to kind of get that front edge square up and down. And I also came here to the parallels on the table and got it square going the other direction. And I just kind of clamped my vise down at whatever angle that was. I don't even know what angle it is. It really doesn't matter. Probably 118 degrees. That's what it should be. But anyway, that's how I kind of set this up where it all be square. Anyway, I thought I'd show that real quick. I also thought I'd show, because you couldn't see what I was doing, I was talking about the side controls. On some of your K&T mills, particularly the bigger mills, I think the Model K mills, it was pretty standard. On the Model H mills like this one, this was an option to have the side controls on it. Fortunately, I've got them. So instead of only being able to control it from the front of the machine, you've got a set of places over here on the side that you control it. Now, obviously, the table I can move in and out. I can reach that from the back side of the machine. You know, normally the operator would be standing over here. I'm standing over here beside it, but there's two places down here. There's a little removable handle that you can just fit up into these. And when I do that, that moves the table in and out. You can probably see the hand wheel on the front turning as well. And then there's another place over here that I can put my handle in, and that adjusts the knee up and down. Additionally, I've got 3 handles over here where I can do my automatic, engage my automatic feeds on this for each one of the axes. This one controls the going in and out. This one controls this axis, and this one here is the up and down. So complete control standing on the back of the machine. And when you're doing something like the operation I was just doing, that is really handy. And I find this extremely helpful for a lot of building operations where I want to be able to kind of get on the back side where I can really see what I'm doing from a different angle, particularly when you're working on facing something, because your work surface is directly behind you. If you're like running a face mill or an end mill or something on this, or a drill bit like I'm doing now. So really handy to have these side controls. Over at my drill press now, I need to drill a hole that we're going to tap for that set screw. I'm going to just do a 1/4 20 set screw on this. Now I took a Sharpie pen and I kind of found the center of the line. I took a square and drew it coming out here straight. So I know that I need to drill that along that line. I don't know how well you guys can see it in the video. And I'm just going to kind of eyeball and try to shoot directly for the top of the circular piece here, or at least close to it. I think that'll make it a little bit easier to do. And I'm just starting again. I'm using a center drill here. I'm using it as a spotting drill, just the end of it. I'm not going past where the straight part comes in, so I'm just getting a little point there to start my hole. And we're going to go with a number 7 drill bit, which is the size for 1/4 20. The drill size, hole size, to tap a 1/4 20 hole. And we'll just drill that in there. Again, drilling very nicely after annealing it. Before it was a little bit on the hard side, but after we annealed it, it seems to be machining just fine. So I am going a little bit easy on my down pressure here just because of my setup in that vise. I don't have support directly under it, so I was just kind of letting it cut as it goes. All right, now we'll take this and tap that and have a place for our set screw to go. All right, we're ready to tap this. I'm just going to hand tap it. This is a 1/4 20 tap, so 1/4 inch by 20 threads per inch. I'm just going to put a little dab of anchor lube on this to lubricate that tapping And again, I'm just going to do this by hand. I'm going to take a little deburring tool and just kind of deburr the face of this. And I'm going to take a little rag and kind of push up through here and just kind of clean that hole out a little bit. Our diamond nib goes right in there. Let me go get a set screw. I'll deburr the top of this as well. Let's put our set screw in. And I think we have our dressing tool finished. Let's go put it on the machine and see if we can dress our wheel. All right, we got our tool mounted over here. It looks like it's going to clear. Everything's going to be fine. Let's fire up our machine. We'll bring our wheel up to the diamond. The back side of this wheel a while ago, earlier, was a little bit higher than the other side. Now after we dressed that, ground that piece on the that we made the holder out of, I don't know that it's still that way, but I'm going to touch off kind of back here on the back side, make sure I'm not in the way of the camera. There we go. And I'll just start sweeping this back and forth. I'm going to bring my wheel in just a little bit. And let me change that camera around where you can kind of see how that wheel looks. If you kind of see that little light green area right there in the middle, that's the area that just touched off. I'm going to bring the wheel in just a little bit more. We'll pull it across there. And we're just getting that wheel dressed nice and flat all the way across, which we really need to make a good cut with our grinding a drill bit. So I want to get that green all the way out to the edge. This will work a lot better under coolant. I'm making a lot of dust right now, but my coolant pump isn't working currently. That's the next thing to fix. I'll make one more little light cut, and I think we'll have it. There we go. Our wheel is dressed. We'll let that stop. What's important when we're dressing these wheels is that you have a flat face all the way across that is flat in the plane that you're grinding, so that when we come in here and actually start grinding drill bits, we're making a nice cut, the same cut all the way across. And periodically you just have to dress these wheels because they're a grindstone. They're going to wear down as you use them. And so you need to dress them from time to time to make sure they're running true. We've got a tool now to do that. I'm real happy to have this added to the arsenal. We're getting really close to being able to actually do some wheel dressing with this machine for real. Like I said, the next thing to do is the coolant pump. But before I do that, there is one thing I can do right this minute that I want to go ahead and get done as well. So when I put a new motor starter on this a while back, I commented that we needed to change out the motor heaters or thermal overload protectors in here to properly size them for the motor. I got the ones that are in here right now are close to being the right size, but they're not the right size, and I had to order the ones that were the correct size. The ones that are in there would probably work fine, but they would kick off a little bit sooner than what they should if that motor got overloaded. So I am upgrading these with the correct one. Now, anytime you're doing electrical work, the first thing to do is make sure you're disconnected. If you've got a mechanical disconnect, a lever, throw that. On this one here, my disconnect is the plug. I unplug it from the wall, and I know that it's disconnected. I don't want to be working on this with hot power. So I'm going to pull this off, And down here at the bottom end, there are the thermal overload protectors, or heaters as they're often called, and we're going to change these out. On this Square D motor starter, there are basically 3 of these heaters in here, one for each of your 3-phase legs, and we want to change them all out. And like I talked about before, you size these to the motor. You look at the how many amps the motor draws at full load. You look on the motor plate to determine that. And I'm going off of memory here. I think this one was 6.8 amps. And then there's a chart that you can look up to see which little heater you need to match that amperage. There's a range that they fit into. And for this one here, it's a B10.2 is what we need. And these work, as the name kind of implies, as a heater. This little strip right here in the middle, when it starts pulling more than whatever the maximum amps rated for this heater is, it will heat this area up, and the thermal expansion will cause this little mechanical piece here to trip, and that will shut the motor off. And it's just there to protect the motor. Because like we talked about before, when I was doing this, if you saw my first video, you know, usually you have a breaker that protects your wiring, but in the case of this machine, my breaker is set for 20 amps. That's how many amps it'll pull before the breaker trips. But the motor can only pull 6.8 amps before you can potentially start doing damage to the motor. So we need for it to trip out beforehand, and this the way this works is this will heat up, it will physically trip out your motor starter, it will turn the motor off, and you have to come reset you push this reset button, that resets all those heaters, and then you can do it. So if you start a motor up under a load, this motor starts getting hot, you can let your motor cool off a little bit, and then reset it, and typically you can run it and you'll be just fine, unless there's a problem with the motor or a problem with some bearings or something being too stiff, and it's just causing that motor to work harder than it should be. Fairly simple to change these out, but they need to be sized for the motor that you're actually operating. And it also helps if you put them in the right way. I got this one in backwards, upside down. Yeah. All right. All right, we got all 3 of our properly sized motor heaters in place, and now I want to just hit the reset button, and that will make sure that everything is set and ready to go. And this is now sized as it should be, so I don't have to worry about that anymore. We'll button this up, and we should be done with this one. And I've got it plugged back in, and it's working like it should. So guys, really the last little final step to getting this whole thing up and going is I need to deal with the coolant pump that was on here and get it kind of fixed up. I'm not gonna go into a lot of detail right now, but here's the situation. The pump that was on here, we're not gonna be able to use. 2 reasons. Number 1, the bearings were worn out in it. Not a deal breaker, but it was a problem. I was gonna have to go in there and rebuild that pump. Second, most importantly, it was only wired for 480 volts. This machine's now running on 240 volts, and it was going to cost me more money to either have that motor rewound or put a transformer on here to deal with it. So I've just got a new coolant pump that we're going to modify the thing so that it'll work. So we're going to more details on that coming up in a separate video, but once that is done, I think we'll have this machine fixed up at least to a point that we can use it. And again, eventually I want to do a full-blown restoration on this, go through, check all the bearings, fix a couple of little issues that I've seen up on top. Nothing that's a deal breaker, keeping it from being used, but some things that we can improve upon. But that's going to be down the road. Right now I just need to get it running where I can use it until we can put it in the queue to get it restored. So that's kind of where we are now. One more step on this and then we'll be ready to start using it. And with that, guys, that is going to be a wrap for today on the Seller's drill grinder. We got one more thing done with our new wheel dresser. That's going to really help us be able to use this machine more efficiently and really take full advantage of it. That was something that was missing when I got it, so we just kind of made a modification, made something that's going to get the job done, and as you can see, it's going to work just fine. So with that, guys, for today, I think that's going to wrap it up. We're going to get out of here and go work on something else. But as always, thank you guys so much for watching. Please, 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 if you haven't already, take the minute, hit that subscribe button. It really helps me out. Also, leave a comment and hit that like button if you like what you saw. That also really helps out with the algorithms on YouTube, helps get my site discovered by other people, and helps me to grow. Also, big, huge thank you to the folks out there who help support my site financially through Patreon and PayPal. As I had mentioned before, I recently retired from my full-time job a little bit earlier than I had planned so that I could come out here and work in the shop full-time, bringing you guys more content. So this is now my money-making opportunity in my life. And while we do make a little bit of money on the videos themselves, really the sponsorships and the help that you guys give and support through the site, through Patreon, PayPal, etc., really is what enables me to do this. So if you have the means to do it, if you have the want to do it, please consider helping out. There are links for that down in the description below through PayPal or Patreon. Both of those help out a bunch, and I greatly appreciate everybody out there that does that. And with that, guys, we're going to get out of here. We're going to sign off, get to work on something else, and we'll catch you guys on the next video. Again, thanks for watching.